Welcome back. We are continuing our lessons on functions, and we are going to look in a little more detail at the graphs of functions today. Let's go ahead and get started. All right, we've taken a look at this particular graph before on our last lesson, but let's look at it again. And what I'd like you to do with this particular graph is get paired up with someone. I want you to work with a partner. And I want you to be able to describe the graph to your partner in as much detail as you can. So if your partner isn't, let's say that your partner isn't looking. One person looks at the graph, one person doesn't. You're going to try to describe this graph to your partner using only your words. Don't draw with your hands, don't draw it on a piece of paper, but only your words. Go ahead and take a couple minutes now and with your partner, try to describe this graph. So, in your attempt to describe this graph, you may have used all sorts of words here, but what we're going to do is we're going to describe this graph now using some math words. And in talking about this graph, or trying to describe its shape and describe what it looks like, what we're going to do is really, to start with, kind of talk about some of the important points on it. And when you describe it to your partner, you may have talked about those important points. So these important points, let's go ahead and get started here with some math vocabulary. Some of the important points that you might look at on this graph are maximums and minimums. Okay, so a maximum on this graph would be the highest point on the graph. Now, if you look at this graph, our highest point happens at R. And our highest point, although it happens in R, you notice that P is kind of a high point too. But it's not the highest, so we're not going to call it a maximum point, and we're going to get into that in a minute, a name for that one in here in a minute. But at our highest point, we have point R. At our lowest point, which is what we call a minimum value, our minimum then happens at point S, our lowest point. Now, how are we going to deal with P and Q? P and Q aren't the highest, they aren't the lowest, but obviously they're kind of important points on our graph. And these points we'll call turning points. Our turning points here at P and Q are basically exactly what it sounds like. It's where our graph changes or turns, and we're going to talk about this in reference to slope. It's where our turning point happens, where our slope changes from a positive slope to a negative slope. So turning points are points where we have a change in the sign of the slope. Now, we were talking in terms of slope. we have a turning point. Positive slope, turns, then we get a negative slope, then we turn, then we go back up again. You might have described it saying you go up a little ways to 102, then we're going to turn and go downhill to about 100, then we're going to turn and go uphill. You might have talked about going down or up. What we're going to do in math terms is talk about it in slope. And these areas where we're going uphill or have a positive slope, we are going to call intervals of increase. So our intervals of increase are the areas on our graph where we have positive slopes. And you can see on our graph that we have a positive slope in this first section all the way up to P. And that's where we turn and go downhill. We're going down. That section then we would call an interval. I'm sure you can guess it at this point. Of decrease. So we have an area of negative slope. At Q, we turn again and go back up. So we have an interval of increase. At R, we go to an interval of decrease. So our graph is divided into these sections of, or intervals of increase and intervals of decrease. And we would list those as intervals using interval notation. So for our interval of increase on this problem, we would say that we're going from 0 to 1 is an interval of increase, and then again from 3 to 5. Our intervals of decrease would be from 1 to 3 and from 5 to 12. Okay? So those are just some general terms that we will use in trying to describe our graphs. Now, one of the things in trying to describe the graph that you may have tried to do was talk about how steep it was. For example, it goes up really fast and really steep between point Q and point R. But as it drops off from R to S, it's not quite as steep. So let's talk a little bit more about the steepness of a graph. It's not exactly an important point, but it is a way to describe our graph. Now, hopefully you can remember all the way back to Algebra 1 when we first started talking about the steepness of a graph. And the word we used there, again, remember, was slope. And you may remember that in order to find slope, what we were doing was finding the change in the y values over the change in the x values. I'm going to represent change with a delta. So the change in the y values over the change in the x values. Now, in our last lesson, or one of our lessons previous, we talked about our y values are really our functions, our value of our functions. So another way that I could say this is it's the change in the function f of x over the change in our x values. The term that we're going to use for this, we can call it slope and steepness, but we're going to get a little more detailed here, and we're going to be looking at what we'll call average rate of change. So our average rate of change is, let me get my graph here again. If we look at our graph, and we want to find our average rate of change between 2 points, what we're going to do is we're going to take 2 points any 2 points we want, and we could take, I'm just going to take from 1. And now this isn't a straight line on our graph, but if we were to draw a straight line between the two, it would be very close to our curve. So we could find the slope of that straight line between the two, and we're going to call that our average rate of change. How fast is it changing, or what is the change between 1 and 2? Or for any graph that we have. So let's take another graph here. Another equation. We'll go back to our parabola. Let's just take a look at this. So if I wanted to find the average rate of change for this equation between -2 and 0, what I'm going to be doing is taking, let's go to -2, and here's 0. I would be drawing a straight line between the two and trying to find the slope of it. So we're finding the change in y or the change in x. What I would be doing is I've got to figure out what is my function at 0 minus my function at -2, change in y. Now remember, we're doing function notation here. So I'm using my function notation instead of my y's, over my change in x's. And what I'm going is I'm going from 0 to a -2. Change in y or the change in x. Well, my function at 0 for x equals x squared, f of x equals x squared, means that I'm 0 squared would be 0, minus -2 squared would be 4. 0 minus 2 is 2. And what I've done is I've found my slope between the two, or my average rate of change would be -2. When we can do this, we can pick any point we want along here to indicate. So let's take this problem. I want you to give it a try. We're going to take f of x equals x squared, and I'd like you to find the average rate of change between 0 and 1. Now, you should be able to estimate here that there will be differences from what we just did. You should know on this section we should end up with a positive slope, and you should be able to kind of estimate it. It's not going to be as steep as the one we just did. So go ahead and take a minute and work through that problem. Find the average rate of change. So on the average rate of change here on this particular problem, you should have been finding the value of our function. We can do from the function at 1 minus the value of our function is 0 over 1 minus 0. So 1 squared minus 0 squared over 1. We have an average rate of change of 1. Okay? Now let's get another graph up here. Now this graph, I'm going to be looking at a couple of different points. I'm going to start right here on my x-axis at A, and my other point I'll take is at point B.